Table 21.1 below gives the standard electrode potentials for 7 redox systems. You need to use this information to answer the questions below. A. Part 1. Outline an experimental setup that could be used in the laboratory to measure the standard cell potential of an electrochemical cell based on redox systems 4 and 5. In your answer, you should include details of the apparatus, solutions, and the standard conditions required to measure this standard cell potential. The general setup for measuring a cell potential is you're going to have 2 beakers with 2 electrodes in. And these electrodes are going to be connected to a voltmeter, and then connecting the 2 beakers, you're going to have a salt bridge. So you need to label all of this in your diagram. And then the next part of the question is identifying what's in your beakers and what your electrodes are made out of. In order to identify what our electrodes are made of and what is in our 2 beakers, we need to take a closer look at redox systems 4 and 5. So here's redox system 4 and here's redox system 5. In redox system 4, we're using a silver solid. So that's going to be what our electrode is made of. We're going to have silver, metal, and then in our redox system 5, we don't have a solid produced or reacting. So our electrode is going to be made of platinum metal. Then we need to identify what's going to be in each beaker. In the beaker on the left, we're going to have 1 mole per decimeter cubed of silver 1+ ions, and they're aqueous. And then in the beaker on the right, we're going to have 1 mole per decimeter cubed of iron 2+ ions, and they're aqueous. But we're also going to have 1 mole per decimeter cubed of iron 3+ ions in aqueous solution. So finally, the last bit of the question is asking us to comment on the standard conditions required. And the standard conditions are going to be 298 Kelvin and 100 kilopascals. In order to get the 4 marks for this question, you must have both cells or half cells correct. So that gets you a mark for each correct half cell. You must have a complete circuit with a voltmeter and salt bridge. That gets you your 3rd mark. And then your 4th mark comes from correctly stating the standard conditions required. Part 2. An electrochemical cell can be made based on redox systems 2 and 4. The standard cell potential is plus 0.53 volts. State and explain the effect on the cell potential of this cell if the concentration of silver ions is increased. Looking at redox systems 2 and 4, so we have 2, there's no silver ions present, but in 4 we have silver ions present. And if we increase the concentration of the silver ions, the equilibrium is going to shift right, and that's going to increase the electrode potential of redox system 4. So we can then write our 2 bullet points. Our first one is going to be that redox system 4, or the silver ion redox system, is going to become more positive. That's our first bullet point. And this is going to mean that the electrode potential of the cell is going to become less positive. So the combined redox system 2 and 4 electrode potential. To get the 2 marks for this question, you get a mark for each of the bullet points that I've written. Part B. From table 21.1, predict the oxidizing agent or agents that will not oxidize Fe2+ aqueous to Fe3+ aqueous. So what we want is for Fe2+ to be oxidized to Fe3+ initially. So that means you're going to need an electrode potential that's greater than plus 0.77. So any of these cell potentials will shift the equilibrium to the left so that Fe2+ will be oxidized to Fe3+. But the question's asking what will not oxidize. So that means that it's going to have to be anything with an electrocell potential lower than 0.77. So the answer is going to be zinc 2+ and Ce3+, or cerium 3+. To get the mark for this question, you must write zinc 2+ and cerium 3+. Both of these you need to write in order to get the mark. Part C. An aqueous solution of iron 2 bromide is mixed with an excess of acidified solution containing manganate 7 ions. Using table 21.1, give the formula of the products of any reactions that take place. The redox systems that are involved in this question are redox system 1, redox system 3, and redox system 5. What's happening is you're starting with iron 2+, bromine minus or bromide ions, and manganate 7 ions. And so your products are going to be on the other side of the equilibrium. So they're going to be your manganate 2+, your water, bromine, and Fe3+. To get the 2 marks for this question, you must have all 4 products.